Sometimes it's up in the air. That's a composite function. We all know that the derivative e to the x is e to the x. Well, I'm sorry, everyone. The derivative of e to the 4x, y equal to e to the 4x, the derivative of y equal to e to the 4x is not going to be e to the 4x. Because it's chain rule. Right? But it'll be kind of like it. So let's try it. Well, if the derivative of e to the x is e to the x, everyone, I'm thinking of this as like, you know, some g there, right? My g is the 4x. So if the derivative of e to just a
G,
e to a g would be
e to the
e to the g, right? Put my g back. That's the f prime of g part. That's the f prime of g part. But what's missing?
G prime,
The chain, which is the what?
G prime.
What's the derivative, Amber, of 4x by power rule? Just a what? You saw it earlier. We had a 10x. It was a 10 or 4x. Was it 4 or 5x? A 5. The derivative of 4x is just a what?
4.
You're done. Although, what's a good way to write that?
4,
4 e to the 4x, right? It definitely looks better. 4 e to the 4x. All right. Hammer, try this one. E to the 4x squared. Can you differentiate e to the 4x squared? Oh yeah, it's e to the 4x squared. Hey, you're close. You're missing something though. You'd be missing the chain. Right? The derivative of e to the 4x squared is e to the 4x squared. Hold up. You'd be missing the chain. You'd be missing the chain. You want to try it? Or question?
Which question?
Oh, go ahead.
So in this case, in the previous problem, g would be 4x.
Yes! And what about here?
4x squared.
Yeah. But notice here I didn't put those parentheses, did I? Because when it's up in the air, it's sitting by itself. I don't have to put it. Right? I put it here just because sometimes you can. Sometimes when they do that E, they just leave the what? They do stuff like that, right? That's G. That's G, right? You got it. I'm going to try this. Y prime e to the 4x squared times,
8x.
do the power rule on that 4x squared, what is it?
8x.
You got it. What's a great way to write that? Everybody okay with this? Okay. I like it. I think you got e's down. And sines and cosines and tangents. Before we trying to do like multiple stuff. Try this next one. Oh boy. Oh boy. This freaks us out, doesn't it? And when we need chain rule. That's not just the square root of x, it's the square root of what? Just listen to my language when I say this to myself. That's the square root of 4x minus 3. Square root of, function composed of, right? That's the square root of 4x minus 3. You bet your g is going to be the 4x minus what? 3, right? Now I think the best way to look at this before we start is, didn't you say we did power rule on these things? How did we do that, guy? We said that was x to what power? So I think a lot of you are going to look at this as what? 4x minus 3 to the... Give it a shot. Would you give it a shot? You know, do your power rule. Half in front. You do have to decrease it by what, though? 1, and then multiply the chain. What's the chain going to be? Just a 4? Yeah, that's easy. But try it. Then you got radicals down. I'll catch up. Tap and decrease it by 1. I get that a lot for the answer. Anything missing? Then. The chain. Oh. What is it?
4.
Now, I would really like you to never leave an answer like that. Students do though, they're so worried they're gonna mess the, they're like, I'll take the hit on the simplifying error. They're so worried they're gonna mess something up. How can I simplify this? What is 4 times a half?
2.
2. Can I move this somewhere? Because I don't like to put negative exponents.
Bottom.
To the bottom. This is way better. Yes, you can leave radicals of these expressions to the bottom, yes. You want to do it. Can you write the radical back? I recommend it. I recommend it, everyone. The best way to write this, to me, is this. You go, why? Because I think eventually, you may have to find the equation of the tangent line drawn to the curve at x equal to 1. Right? What if they said that? Find the equation of the tangent line drawn to the curve at x equal to 1. All you simply have to do, there's the slope, plug in a 1 in for the what? The slope, and it looks nice and easy. Square root of 4 times 1 minus 3 will be easy. Josephine?
I was gonna ask that, like, if you're trying to find the equation for the slope, what do you do with things that are like, well, like the ones we did before, where?
We can use this one right here for a good example real quick.
Well,
Watch
no,
this.
I meant specifically 5x plus 7 to the 41st. Like, what do we do with stuff like that?
Oh, you would plug in, I'd say, find the equation of the tangent line drawn to the curve at that, to that curve at x equal to 1. Well, at x equal to 1, how do you find the y value associated with 1? You plug the y value into the original, but how do you get the slope? It'd be that derivative. And you'll have your crazy derivative there, and then that slope, you find that slope evaluated at the value of 1. You just substitute 1 into that equation. Right? And this one too, look. This is just as bad, Josephine. Look at this. Hey, find the equation of the tangent line drawn to the curve at this point. Okay? Oh, I mean at the point x equals 1. So when at x equal to 1, what's the y value associated with this on this original curve?
4 minus 3, 1.
4 minus 3 is 1. What's the square root of 1?
1.
So could you find the equation of the tangent line drawn to this curve at that point? You would say y minus y sub 1 equals m times x minus x sub 1. Right? But how do I get m? M is the what? This. But where do you gotta evaluate this? See, Josephine, we won't squeeze all that in there. We evaluate this slope at what x value?
1.
At x equal 1. And what is 2 over square root 4 times 1 minus 3? Done. There it is. That's the tangent line. That's the equation of the tangent line drawn to that curve. Right? Cool?
Can I ask you something?
Sure.
What happens if there are like a multiple inner functions?
Oh, there you go. We're getting to that soon. That's coming up.
Okay.
That's coming up, everyone. Did you hear him? You know, like, you go, what are you talking about? Well, sine of 2x times cosine of 3x. Cool. So we'll do some of those. In fact, I got some here that I want to do. Give me a second.
All right.
All right, everyone. Hey, can we do one more square root? I want to do one more radical, and then I'll be pleased. I'll notice everyone's good with trig functions, exponential, radicals, and then we're going to do what Art said. Like multiple functions composed of others. What are you talking about? You'll see when we write it. Not too bad though, but you got to build. You follow me? That's what's wrong with this. If you didn't like some problems in it. Like by number 3, Stuart's problem is like, whoa! And you gotta do like 10 in a row before you're like, I'm confident on this. Then you step it up. Just one more radical. Try this one, everyone. X squared plus 60. Can you differentiate that? They would just say differentiate it. And what do you mean? Find the derivative of y with respect to x. Remember, we don't need this thing anymore, do we? No. It's like, you're done. They write it 2 ways. Hey, do you notice this too, everyone? Remember I used you earlier? Even you, Josephine, may prefer this. Look how I'm writing this. DYDG, DGD. I mean, that's really what's going on. That's really what's going on. It's another way to say it. Oh, what's the GGDX? That's the what? That's the chain. All right, I'm gonna try this. First of all, I'm gonna write this as all this to what power? What power is it to? All right? So I'm gonna take that half, multiply it in front, decrease it all by what? 1, I'll put my G back in. I think I'm done, am I? No! I'm missing what? The derivative of x squared plus 16. Looks like you're gonna have to do power rule on that. What's the derivative of x squared plus 16?
2x.
2x. Do you agree? Amber, are you okay with that? What's the derivative of this? 2 in front, right?
Yeah.
Oh, good. What's the derivative of plus 16?
Okay.
And what's the derivative of plus 16?
0.
Yep. So it's really 2x plus 0, but we're just gonna say what? 2x. And we don't even need the parentheses when you just say 2x. Now, does anything cancel? Bye-bye 2's. So what's a great way to write this answer? Look at this. What's it, what letter right there? X. Let's leave that in the numerator. What can go down to the denominator? X squared plus 16. All raised to the half power. Kelly says, but hold up. If you got x squared plus 16 to the half power in the denominator, you can just write it with the what?
Square root.
That's the preference. That's how we should write it.
What happened to the 2?
Are you okay?
Yeah.
All right, I'm almost there.
Okay, cool.
Which is good, no. It's like, take it slow. You notice sometimes I do just an x or 5x, then I might go up to an x squared. And Amber, you're always thinking power rule, right? All right, try this. You go, hey, why is Messenger doing that? We've already done that one. I said, well, I haven't done one where there's a 5 in front. And that little 5 somehow throws students off. So this is what I mean, how we gotta build it slowly. Right? You gotta build slowly. Just that 5 throws people off. You go, oh, what do I need? Something else? What do I need? Do you remember the constant rule? I know I never write it down. What's the constant rule say? If there's a constant in front, can it just hang out through the whole problem?
Yeah.
Yeah, so don't let that affect you. Let that 5 just sit there. Let it just stay. 5. Now what's this derivative of this guy?
Negative sign.
Now remember I accidentally did 5 minus before? I'm going to put parentheses so we know we're multiplying these. So 5 times a negative sign of something. I'll put my g back. Sign up. 4x squared. What's g prime now? Because I'm calling that g. 8x? 8x? Now what's the best way to write this answer? That is not 5 subtract. And I'm so glad you brought that up earlier. That's 5 times a negative.
Minus 40.
That's 5 times a negative sign. So the final answer is just going to be negative, right?
Yeah.
Negative what?
Negative 40x.
There you go. Well, I love how you are saying this. I love how you are saying it's negative 40x sine of 4x squared. Right? Now some of you might bet, I thought I had to do product rule because of the 5. If it's just a constant, you don't need product rule. Right? Everyone agree? If it's just a 5, you don't need product rule. When do you need product rule? Stuff like this.
X squared.
And I'll do something simple where you don't need chain rule. When do you need product rule? Look at that carefully. What's in front of cosine x? X. See? A variable. That's when you need product rule. And you go, do I need chain here? No. You don't need chain. right? Someone say that?
Mhm.
This is when you need product rule. X times cosine of X. But this was just a what? 5. So every time there's a constant, are we gonna worry? No, just let it kind of hang around, right? It's almost like you can hide it, do the whole problem, in the end, multiply the 5 back. True? By the way, let's do one like that then. Ready? All right, now we're starting to build. See, this is the first time, everyone, I've taken chain rule and put some other variable in front of it. What are you talking? Oh, the sine of 2x, but now there's an x in front. So here's my question. Someone's going to know this answer. Where do I begin? What's the overriding rule I should start with?
Product.
Product rule. That's what I'm going to do. When I'm looking at this problem, everyone, remember I like to use m and n? I'm like, okay, you're m, and this whole thing right here, you can tell it's a composite function. I'll just call that n. But you might call it m times n composed of O. N is composed of another part, right? But we don't need to make it too complicated. We get it. But when I'm going to write out product rule, but I'm starting with what rule? Product rule. Because what was in front of the sign of what? An x. Do you follow me? So here we go. Product rule. M times n prime plus
In.
n times n prime. If you hate m and n's, you can use f and g. But some of you say first times the root of the second plus second times the root of the first. Well, 3 of these are going to be real easy. One of those 4 pieces, I want to make sure you do fine. 3 of these things are real easy. Let's start with. Watch. What's m? That's easy. What is m?
X.
Oh, that's easy. Okay? And prime.